morning. I'm Frank Fitzgerald, Product Manager for Teco Electronics, Raychem Products, and the cable accessories. For those of you who don't know what cable accessories are, there's a couple examples right behind me. The ones on the left are 750 kc mil 25 kV cable. There's 3 cables there, the black things, and they're feeding this entire industrial establishment of about 7 or 8 factories and several other residential areas, all through those 3 cables. The little gray bits on the end of them are cable accessories. Those are actually terminations. The accessories on the right, the pole on the right, has 3 smaller cables, and those are feeding our actual facility right here. So if those go out, our entire facility goes out. Cable accessories are somewhat taken for granted, but they are a critical part of the distribution system. Today we're going to talk about the proper installation of those terminations and some splices. We're going to talk about how they are tested and meet some of the people who really know how to put them on and teach other people how to put them on. So right now we're going to go inside the plant and meet these people. Come on. This is one of the combination labs that we have at the Raychem, North Carolina facility. This one we have some testing going on over here. It's a good idea to mind those signs because some pretty dangerous things happen inside that cage. But primarily this lab is the place where we teach our customers how to install our products and give them a chance to install them so that they learn the techniques for installing, in the past, heat shrinkable products, and hopefully in the future some cold applied products. This is one of the somewhat more complex products that customers have installed. This is a heat shrinkable Y-splice. We're not going to show you that today, but we are going to show you some other products. And we're going to get with Dennis Lynch. He's the master cable splicer. He's been doing this for 40 years. He's currently the medium and high voltage cable accessory product manager for North America. So I'm going to go talk to Dennis right now, see what he's up to.
Frank, how you doing?
Good.
All right.
This is Dennis Lynch.
Hi.
He's the medium and high voltage cable accessory product manager for the Americas. Dennis is going to show us how to do a heat shrink cable splice right now on 15 kV copper tape shielded cable.
In here we have the stress relief material. This moisture sealed envelope.
And a special bag to keep the
to
moisture
prevent
out.
moisture getting at the material. What you have to do with the long strip is remove one side, the side with all the writing on it. Remove that and then roll it up in a nice tight roll. And then apply it over the connector, filling in these gaps at the insulation cutback. Build up to a little bit over the diameter of the cable insulation and go onto the insulation about 1/4 inch. And this stuff, you can stretch it as much as you like so you can make a nice, tight, neat installation.
So you're just filling in any voids, Dennis?
Yeah, this is a stress relieving material and a void filler so that there are no air voids trapped under the heat shrink tubings.
But that's not semicon, right?
No. So that's about the right diameter. You see it's about the same, just a little over the diameter of the cable insulation. Then we use the same material, these little angle cut pieces. Remove the backing. Remove both backings from that because it's so small. And we have to fill in this little step at the end of the semicon because otherwise, if we didn't, when you shrink the first tubing on, you get air trapped there. A ring of air would be trapped, and that air, when they energize the circuit, it would ionize and discharge, and then eventually, with the discharge, it would damage the cable insulation, and eventually you get a failure. So we just fill in this little step. Don't need to put too much. Go 1/4 inch onto the semicon and 1/4 inch onto the insulation, and that's sufficient. Do that at both ends. next step is to put a little bit of this discharge control compound, which is basically a highly refined silicone grease, and we just put a thin smear on the yellow mastic, and that is to prevent the first heat shrink tube we put over. We don't want it to stick to the mastic, because in summertime, when the weather's hot, this mastic can get a little tacky. So we don't want to the first tube to stick to it. I should mention, prior to installing the connector, this is just a cable sample as you can see, but in reality in the field, prior to installing the cable connector, you must put the tubes over the cable. They can nest all 4 tubes together like so. This is the rejacketing tube, and put them all over the cable together, or these 3 tubes can go one side and the rejacket on the other side. This first tube, this black tube, is the stress control tube, and you centralize it between the cable jacket cuts. This cable we're using here is a copper tape shield, but this splice is good for uni shield, wire shield, and copper tape shield cable, or lead sheath cable even. So the first tube, you just eyeball it, centralize it between the jacket cuts, you know you've got it in the right position.
And that's not semicon, right, Dennis?
Not semicon.
Definitely
no.
not semicon. It looks like it, but it's not.
But it is not. You have to be aware that you must get the heat around the full circumference of the tube, otherwise it doesn't shrink correctly. Adjust the flame.
It's important to use the right torch too. If you use the wrong torch, like a Bernzomatic torch with a pinpoint edge, you'll burn the tubing. You have to use a torch that has a bushy flame like that.
So you see I've repositioned the flame to point down the tube now, and now I'll reposition it again to do the ends. And go back to the center once it's shrunk on that side. Be careful not to start to shrink these tubes over this side. And then finish it off with a little flame brushing just to make sure you've got it properly recovered. And that's the first tube completely installed. That tube is followed by this red insulating tube, which is positioned in the same position. They're approximately the same length, and you shrink it in the same way. Keep the flame moving so that you don't scorch the tube. However, if you do scorch it, we don't recommend that you do scorch it, but if you do happen to scorch it, all you do is just clean that scorched area with some solvent, and if it's really badly scorched, you can abrade the scorched area away. Flame brush it. But if you hold the flame on it in one place too long, it will scorch, as I'll show you. Now you can see it's burned. But if you let it cool off and take some solvent, that will wipe away, and as I said before, if it's badly scorched, you can just abrade it with a very fine abrasive. But prior to putting on the last tube, we installed the internal moisture seals with this red sealant. Put it on the cable semicon, and you put sufficient to bring the diameter of the sealant to the similar diameter of the red tube that's just been installed. The red inner layer is insulating, the outer layer, the black layer, is conductive. And the 2 layers are co-extruded, so there's no chance of any pockets of air between the 2 layers. If you have air between the 2 layers, you get ionization and discharge, and it's something has to be avoided. So you put this over, and you see it lands on the sealant because it's a couple of inches longer than the previous 2 tubes, and you shrink it down onto the underlying tubes and the sealant, and you get a perfect moisture seal at these ends. So should any damage occur to the cable jacket up the line somewhere and moisture comes down under the cable jacket, it would reach this sealant and would go no further. It wouldn't get inside the inner working part of the splice. This tube is a little thicker, so it takes a little longer to shrink.
Then it's the outside of that's conductive.
Yes, it is.
So that's like the shielding of the cable.
Exactly.
So you've rebuilt the cable.
Exactly. We'll put copper mesh shielding overall, so that will connect the outer layer, this conductive outer layer, to the cable semicon. So shielding.
You got a stress control inside.
Yeah.
First there was void fillers, then you put a stress control, and you put insulation and conductive.
Right.
I got it.
But all these components are factory engineered. So if you follow the steps that you'll see in this video that I'm doing, a quality installation will be assured. We'll do the flame brushing. Now we install the ground braid. You have to make sure that this braid makes contact with the copper tape. Some people, when they install this, they put the roll spring on first, like so, and then the ground braid, because it's easier to install if you do it that way.
That's right.
However, this roll spring is not a great electrical conductor, so not like the ground braid, which does definitely have to make electrical contact with that copper tape shield.
And that ground braid's copper?
Yeah.
Tin coated copper?
Tin coated copper wires, very fine wires. Just give it a little twist to tighten it up. Little bits of adhesive back copper tape, just to ensure that the roll spring stays in place. So 2 layers of the roll spring over the braid, fold the braid back, and then the remainder of the roll spring overall.
And that just makes the shield continuous across the joint, Dennis?
Yep. Then we have the copper mesh. You can cut this excess braid off or just leave it in place and tie it down with the copper mesh. This copper mesh is for personnel safety. Should anybody unfortunately spike the splice, the voltage will go through this mesh to ground instead of through the spiker's arm to ground. That's the idea of it. And then tie it off with a half hitch. Then we have to get some abrasive strip, some solvent. What you do is solvent clean the cable jacket, make sure there's no grease there, and then take an abrasive strip and rough the jacket up to take the shine off it. This is a 120 grit, and just rough this jacket up, take the shine off it. That makes sure you get a good moisture seal.
And this is to replace the jacket, Dennis?
This is replacing the jacket.
Okay.
And to shrink it in the same manner that I shrank all the other tubes.
Now a lot of these tubes look the same. At least they look black, and
yeah,
they all look kind of black and similar, but they do have different functions. And this one is used primarily to replace the jacket and provide a little bit of mechanical protection for the joint. And you can tell this one shrinks a lot faster than that last one you installed because it's thinner. Is that right?
Because it's thinner, right.